Hi, this is Rakesh Gupta, and this is my take on question 1 of the end term video assessment.
Okay, so let's start by seeing what is given in the question. So it is given that there is a container which has 20,000 cubic feet of air. I'm just going to write cubic feet as CF, and the fresh air inflow is given as 600 cubic feet per minute. So 600 cubic feet per minute. And so when the air goes outside the container, it is not all fresh. It is mixed of fresh air and the other kind of air which is present. So I'm just going to write the mixed air outflow rate is given as 600 cubic feet per minute. So now at any, because the inflow rate and the outflow rate are the same, so at any instant the amount of air in the container is going to be a constant, which is 20,000 cubic feet. Is constant, which is 20,000 cubic feet. So now it is also given that Yt is the amount of fresh air at any time, instant t. We can also say concentration. Sorry, this is fresh at any time t. So then y dash of t. So when you differentiate the concentration of fresh air at a time t, when you differentiate it with respect to t, so you will get the rate of change of concentration of fresh air. So now, the rate of change of concentration of fresh air, which is given by y dash of t, is nothing but the inflow rate of fresh air subtracted with the outflow rate of fresh air. Now, we know that the inflow rate of fresh air is given by 600 cubic feet per meter. So we're going to write it as 600 subtracted with the outflow rate of fresh air. So now, to calculate the outflow rate, we can just cross multiply. So if for 20,000, not 2, sorry, 20,000 cubic feet of air, the outflow rate is 600. So for 1 cubic feet of air, the outflow rate is going to be 600 divided by 20,000. So for 1 cubic feet of air, as it is, as the outflow rate is this. So for the outflow rate of fresh air is going to be 600 by 20,000 multiplied with the concentration of fresh air present in the container at that instant. So now I'm just going to write this in a simpler way. So So this is our differential equation, which now we will be solving. I'm just going to rearrange. So now we integrate on both the sides from 0 to, sorry, from 0 to y, and this from 0 to t. So when we integrate, the integration of this term is going to be ln of 600 minus 0.03y multiplied with 1 by minus 1 by 0.03 plus the constant of integration, which I'm just going to write it as ln c, as it is a constant, so it won't matter if I'm writing it as ln or just. So integrating on the right hand side, we just get t. So now I'm just going to take minus 1 by 0.03 as common and write this as also ln a plus ln, I mean ln a plus ln b is ln of ab. I'm just going to multiply c, the constant c, with the inside term over here. I mean, I don't think this is clear enough. So as I'm taking minus 1 by 0.03 outside, and I'm going to take it common from the constant 2, so it is still going to remain a constant, so it doesn't matter. Now I solve further. So I take this 0.03 to the other side, so I basically just rearrange. Now I'm just going to remove the ln. I'm still just rearranging the terms. Dividing the entire equation by 0.03. So now this is at any instant t. This is the amount of fresh air present in the container. So it now it is given in the question that it is an initial value problem which says that y of 0 is 0. So we just substitute t as 0 and we get y also as 0. So then 0 is equal to 20,000, and e power 0, this is basically going to be 1. So I'm just going to write this as 1. This was just rearranging. We get C as 1 by 600. So now we substitute the value of C in this equation. Put an arrow. We substitute this in this equation, so we will get this 0.03 multiplied with 1 by 600, which is just the 600 is just going to go to the numerator. I'm just going to take 20,000 common over here. So this is our final equation of the concentration of fresh air present for any time instant t without any constant of integration. So now it is given in the question that 90% of the air inside the container is supposed to be fresh. So as we know that the total amount of air present in the container, it is going to be constant, which is 20,000. So 90% of 20,000, it's going to be 18,000. 90% of 20,000 is 18,000. So we have to find out the time t for which the concentration of fresh air, which is given by y, is 18,000. So I'm just going to substitute it in the equation. This goes 2 into 10 times, and this goes 2 into 9 times. So 0.9 is equal to 1 minus e per 1 is 0.03 t. I'm just rearranging 0.1. Now I'm going to uh, take log on both the sides. Sorry, I'm going to take ln on both the sides. So I have a calculator over here which says that ln of just a minute. So the calculator says that ln of 0.1 is minus 2.30. I'm just going to write it minus 2.3, and ln of e power minus 0.03 t can be just written as minus 0.03 t. So it is 2.3 divided by 0.03. Yeah, so the calculator, according to the calculator, this thing is 76.66 minutes. So the conclusion is that for the container to be filled with 90% fresh air, it is going to take 76.66 minutes, and the differential equation is this. Sorry, the equation for calculating is this. That's all. Thank you.